Recently, I wrote a bot that beats several Mario Party DS games using computer vision. Since you guys seem to like that a lot, here are some more. I started with Hedge Honcho, where you need to shove away leaves as fast as possible in order to win. You have to watch out though, because sometimes a bee appears, and you need to wait for it to fly away. If you don't, it will sting you and you can't move for a short while. There are also ladybugs which you have to shoo away by swiping over them for a few times. This game seems complicated to automate at first, because there are no clear points where to even start. We need to detect the currently active leaf, and also from which direction it is coming. You could try to detect the edges of the leaves, but filtering out which one is currently active may become a problem. You could also try to blindly shove in all 8 directions, but that won't be enough to beat the very strong expert AI, because of all the wasted time. After I took a closer look, I noticed that the veins on the leaves are the brightest part of the image, and that gave me an idea. I could filter out everything that's darker than the vein with a threshold function and be left with just the information I'm interested in. Not only would this help me identify the currently active leaf, it also gives me the direction I need to shove it in. Here you can see my workflow. First, I turn the image grayscale, so I don't have to deal with colors, only brightness levels. I then determine the brightness of the vein and use OpenCV's threshold function to mask out all pixels that are dimmer than that. The result is a bit too noisy to get a definitive direction though, but it's possible to extract the information we want. For that, I can make use of the Huff transformation, or more specifically, the Huff lines implementation in OpenCV. It takes an image and some parameters like minimum line size and returns the start and end points for perfectly straight lines that were detected on the input. Putting all this together, here you can see that the detection is working quite decently, although I'm still moving the mouse manually. The next step is to figure out how to move the mouse. A naive solution would be to simply use the line that was found and move the mouse from the start to the end. Let's see how that goes. Well, it kind of works, but sometimes the leaves get stuck, and of course we haven't dealt with the ladybugs and bees yet. To detect them, we can use color checking. Since neither red nor yellow appear anywhere else on screen, it is very simple to use the inRange function from OpenCV to check if an insect is present on an image. I simply perform the insect check on the frame before doing any action, and then continue with the existing logic. If a bee is detected, I can just wait until it is not detected anymore. For ladybugs, I need to find the location and drag my cursor across it until it is gone. To visualize the detection, I added little indicator areas on the output. After testing it, it becomes clear that this is not enough to win against the expert AI though. It's possible to continue shoving the leaves way before the insects leave the screen. So instead of waiting for them to be fully gone, I set a timer every time one is detected, and as soon as the timer expires, I let the bot continue shoving leaves. For bees, for example, it's possible to continue just 350 milliseconds after the first detection, and for the ladybugs it's quite similar. Now, it's time for the final attempt against the expert AI. The bot barely wins, but the expert is pretty difficult to beat, so I'm happy with it. Let's continue to the next game. Trace Cadets is a drawing game where you have to trace the shapes given to you on the top screen. All the shapes that are highlighted can be drawn in any order, but drawing them can be quite finicky. The obvious first step to automation is to detect the currently highlighted shapes. For that, we need to isolate them from the background to perform some more processing. Since all the shapes are outlined by the same color, I started by filtering out all colors other than the outline. I used the same inRange function from before and I'm left with this image. Next, I want to extract the actual shapes from the mask. It may appear like we already have a workable image, but first of all, we need to tackle the shapes one by one, and more importantly, the shapes are too thick right now to simply draw them as they are. The easiest way I could think of to isolate them is the find contours function, which I used in several games already. It's looking for clusters of non-black pixels though, and in our image, those may be adjacent to pixels of other outlines. To avoid unintentionally combining shapes, I simply inverted the mask with a bitwise knot function, provided by OpenCV. That way we are actually finding the internal shapes and not the outlines. After running find contours, we are left with a neatly defined list of pixel coordinates that make up our drawable shapes. And it seems the detection is working quite well in game, but of course I'm still drawing manually here, which you can tell by my pathetic non-robotic mouse movement. The next and final step is to take the shapes I detected and to turn them into actual position instructions. I select the first shape contour and prepare it for drawing. First, the position needs to be normalized. Each contour may be located anywhere on the current image, but to draw it, it should be in the top left corner. By finding the top leftmost pixel and subtracting the XY values from each entry in the contour, we end up with the shape in the correct location. The contour is a bit too small though, because the top panel with the shapes is smaller than the drawing canvas. After experimenting a bit, I ended up with a scaling factor of 3.1, and now we are finally ready to start with mouse movement. I can simply write a loop that iterates over all positions in the selected contour and moves the mouse from one to the other. Here's how that goes. No, come on, get it. I mean, it got some of them, but for some reason it refuses to get some of the shapes, no matter how perfectly they are drawn. It actually took me quite a while to find out what's going on. The shapes I was drawing were too perfect. Jumping from corner to corner without intermediate steps confuses Mario Party's detection algorithm somehow. The solution is to insert interpolated steps where the mouse moves to. It doesn't change the drawn shape at all, but for some reason that way the drawing actually succeeds. Anyway, here's the final run. We win against the expert AI with 2 pieces to spare, and I'm pretty happy with that. Before we move on to the next game, I wanted to thank you guys for the amazing support on the last video. We somehow reached over 1000 subscribers, and the girls really delivered in the comment section. Keep it up. For the next game, I picked Cherry Go Round, because it's one of those games like Pokemon Ranger, where you either destroy your DS or you lose. The game gives you 5 seconds to draw as many circles on the touchscreen as you can. And the more you drew, the farther your cherry will be thrown. Automating this game boils down to figuring out how to draw circles. Luckily, I was able to reuse the circle segment function I wrote for Goomba Wrangler in my other video. It works by determining points with a fixed radius and polar coordinate space, and then converting them to Cartesian coordinates that I can actually use. A circle here consists of multiple linear segments, and the more I use, the rounder the circle becomes. It's not necessary to use too many segments though, as the game is quite lenient towards what is considered circular movement. I wrote a simple loop that iterates over the segments and moves the mouse accordingly. Here's my first try in action. I mean, it did something. And trust me guys, I really wanted to go over phase spaces and multivariable optimization with you, but I literally changed the radius and wait time between segments and got this. And since 200 cm is the maximum score you can get, you will have to subscribe to learn about that in a future video. Leave a comment which minigame you want to see destroyed next. I put a link in the description that lists all the minigames to refresh your memory. See you in the next one.